Hey guys, so we're going to review all of these reactions that we've learned recently real quick, as well as do a couple practice problems with them. This table here summarizes the reactions that we've learned so far in terms of um, fatty acids and lipids, and it compares them to the reactions that we learned in our previous section. So, for example, we did esterification when we did esterification of organic reactants. So the smaller molecules, non-biomolecules really, we had that carboxylic acid and alcohol coming together with acid and heat to make ester and water. Well, it's the same reaction with a fatty acid. So you take 3 fatty acids and glycerol with your enzyme and make your triacylglycerol and 3 waters. We also have our hydrogenation reaction. So that's taking alkenes and making them more saturated. And then hydrolysis and saponification. So hydrolysis is the word for water splitting. Typically, you call it a hydrolysis reaction when it is a acid catalyzed process overall, or a saponification if you are breaking an ester using, it's really hydrolysis still, but saponification is where you're using basic hydrolysis conditions. So let's go ahead and practice. So this first problem says draw the triglyceride formed from glycerol, oleic acid, linoleic acid, and lauric acid. So I cheated and went ahead up to my notes up above, but up above in our notes, we had charts with all of the different types of fatty acids. And so you should make sure you have access to that. I hopefully will remember to, on your exam, make sure you have access to either the charts, or I will just give you these numbers like I did my little cheats above. So we have our 18-1, that means it's 18 carbons and 1 double bond in that carbon. That double bond is at the omega-9 position for oleic acid, or linoleic acid is 18-2 with omega-6 and omega-9, and then lauric acid is 12-0. So I'm going to go ahead and draw the final product because I know that I can start with my glycerol. So I'm not going to draw those carbons this time. I'm just going to draw my oxygens. I'm going to go ahead and draw my carbonyls on here, and then start with my fatty acids. So I like to start just drawing out all of the carbons all the way across. Actually, it's a little bit tricky because you want to make sure you get that kink in the correct place for these omega-9 and omega-6. So really, you're going to want to subtract. How do I do this? You're going to want to subtract to make sure that you have your double bond in the correct place. So if I know I have 9, my double bond starts on the 9th carbon in, I'm going to do 18 minus 9, which is 9. But that's where my double bond ends, not where my double bond begins. That means my double bond begins 8 from the other end. You can also just draw it and then erase and draw in your double bond. But I have 1 carbon here, 2, 3, 4, 5, 6, 7, 8. Make sure this is right. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it does start at the 9th. 9. Double bond. 2, 3, 4, 5, 6, 7, 8, 9. Let's check and see if I did this correctly. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. The omega-9 position, I have a double bond. 10, 11, 12, 13, 14, 15, 16, 17, 18 carbons long. Okay, so let's do that again, maybe a little bit more gracefully this time. So at the omega-9 position again, when I have 18 carbons, so it's going to be the first one I hit when I'm drawing from the alcohol end or the ester end. So I'm going to take 18, subtract 9, and what I'm left with is where that double bond is going to start. So don't mind what I was saying about 1 minus. I was being dumb. So we are going to count 9 carbons. At carbon number 9 is where our first double bond is going to be. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. double bond. Then at the omega-6 position again, I believe, I lost count. 1, 2, 3, 4, 5. One more. Let's count and see if we're right. 1, 2, 3, 4, 5, 6. At the 6th position, we have a double bond. 7, 8, 9, we have omega-9. 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 carbons total. Okay, and then our last one is the easiest. There's no double bonds, so it's going to just be 12 carbons long. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's go ahead and just label them just to keep it track. This one on the bottom is lauric acid. Then we have linoleic acid. And then oleic acid on the top. This is a lot of trial and error. I typically just draw and erase and draw and erase until I triple check it and it's correct. Okay. Number 2, fill in the rest of the balanced equation for the complete hydrogenation of glycerol triolate shown below. So you can use any shorthand notation. So if we're going to do a hydrogenation reaction, that means we're going to remove the double bonds, make them saturated. So let's just highlight these double bonds here. So these are what's got to go. So we're going to add 3 hydrogen molecules and have some kind of catalyst. So I'm putting nickel because that's my favorite, but you guys can choose what you like. And then I'm going to draw my triglycerol. So now I know that I'm going to have the same number of carbons and they're all going to be saturated. So I'm going to use the shorthand notation. Oleate is 18, 1. So if I counted all of these carbons in each of these chains, there should be 18 carbons in them. So that means if I go like this on each of these, I have 1 carbon here, 1 carbon here, and if I put parentheses around this middle carbon, CH2 is what repeats all the way down. If I subtract 2, because I have 1 carbon on each end, that's different, I'll have 16 left, and that is my shorthand notation. So we have 16 in the middle, 17 because we have 1 on the end, 18 because we have 1 carbon on our carbonyl. So we have 18 total. I'm not going to go through and count, but you'll notice if you count all of these, it's 18. So this is our final product. Okay. And lastly, fill in the rest of the balanced equation for the saponification of glycerol tristearate shown below. So I went ahead and wrote that it's 18-0 for tristearate, so that I didn't have to count these carbons in front of you. And then saponification, so that's our hydrolysis in base. That's when we're making our soap using sodium hydroxide. So let's pick a final color. Okay, so if we have this triglycerol here, we're going to add 3 sodium hydroxides because we have, for a balanced equation, we need to have all 3 for each of the esters that we have. And we're going to add heat to the reaction. And that leaves us with glycerol. And 3 of the carboxylate salts. I'm so sorry, it gets so wonky at the end. It's so weird. Maybe we zoom in, it'll do better. 3 of our salts. And again, we're going to do the shorthand just so that we have, we don't have to draw so much. So that's the exact same notation. We have 16 of these units here that are all just CH2. So I'm going to show them as 16 in parentheses to show there's 16 repeats of that unit. Okay, those are our practice problems with this, and I'll see you guys in the next video.